Hello folks, welcome to 2.5, where I'll be working with negative rates. Here is your journal page set up, and a lot of what we're going to do today is take some of the general skills we've been learning in the last several lessons and use them to solve word problems. And that is indeed our standard, which is 7 NSA3, where we are solving real-world mathematical problems involving all four of the operations using rational numbers. So your learning targets today are: I can solve problems that involve negative rates, and I can solve problems that involve multiplying and dividing rational numbers. To get us started, let's talk about some pieces of vocabulary. So in our past several lessons and in last unit, we've been talking about elevation. Elevation, again, being where 0 is sea level and everything above is our positive numbers and everything below is our negative numbers. When we're talking about altitude, we're no longer talking about 0 as sea level. Altitude is above or below a certain point. So in a lot of the problems you're going to see today and in this lesson, you're going to be given a specific point that isn't necessarily the ocean, and that will be your 0. So you can see from this picture, altitude is used a lot for airplanes. And even though these planes look like they're at the exact same place in the sky, they have different altitudes because this first plane that I just circled is kind of up on a hill. You can imagine maybe that's like a little mountain. And then the second plane that I'm circling right now is more down in a valley. So it is actually higher above the ground than the other plane, even though they're at the same place in the sky. So again, altitude is really dependent on a given point. And I really like this image over here as well. Let me bust out my nifty highlighting tool, where you can see elevation starts at the sea and then moves up. So the elevation of that airplane right there is above the sea level, but the altitude is above a given point. So again, those would be different numbers. And we'll also be talking about an ascent and a descent. So ascent or ascending is the act of rising in altitude. And you'll often hear this if you've ever ridden on an airplane. When an airplane takes off, it is ascending. Oh, I should do that in blue. Ascending. Descent is the act of going down in altitude. So when an airplane is landing, it is descending. Interesting, it doesn't say that there, but that's what that sentence should be. When an airplane is landing, it is descending. So elevation versus altitude, when we're talking about negative numbers, elevation, we will see negative numbers represented on how many feet below sea level a submarine is. And again, sea level is important there. Altitude, we would be using negative numbers to represent how many units below a given point we are, like dropping down into a cave that is on a mountain. So you might still be really high above the ocean, but you're moving in a negative direction because you are going down from your given point. All right, so for word problems, this is something that a lot of students struggle with, and it's actually something that I mix their struggle with too. And here is how I work with word problems. Every time I'm reading a word problem, I read it 3 times. The first time I read it, I'm asking myself, what is the situation about? What words don't I understand? This would be your time to go onto Google and Google search what different words are if there's something you've never heard of before. And just generally getting the idea of what the whole problem is about. The second time I read it through, I am specifically looking for countable or measurable pieces of information from the story. So that's generally going to be your numbers. So for your second read, look for your numbers. So by countable, you can just say numbers. And for my third read, I'm asking myself how I might begin to solve the questions. So I'm like, what are they asking me to do? And how can I use what they've given me to solve the question? So we're gonna start with some of these by talking about this place in the ocean called the Challenger Deep. It is the deepest known point in the ocean, and we're being given our first piece of key measurable information, which is that the Challenger Deep is 35,814 feet below sea level. So we're about right here in Oregon. And then here's Hawaii, and the Challenger Deep is way across the ocean right there. So in these problems, we're going to be talking about these oceanographers. So in 1960, so oceanographers are people who study the ocean, first of all. And in 1960, oceanographer and engineers Jacques Piccard and Don Walsh rode down on a submarine named the Triste and became the first people to visit the Challenger Deep. Jacques Piccard had to design a very specific type of submarine to make such a deep descent. And this is a picture of that submarine he built. And this is a picture of them inside the submarine. And they are actually in this little, oh, you can't really see that. Let me get a different color. They're in this little bubble right here in that picture. So they would be in there, and the rest of this is all something that just like helped keep this machine sinking into the ocean and upright so that they didn't flop upside down. Okay, so for the actual problem, Triste, again, that is the name of the ship. Triste's descent, so we're going down, was a change in depth of -3 feet per second. We can use the relationship position equals velocity times time, something that should be familiar to us by now. Using this model, meaning position equals velocity times time, how much time would it take the Triste to reach the bottom of the Challenger Deep? And I put this here in case you don't have it in your notes. Go ahead and pause this and see if you can figure it out yourself. So I'm going to start this by writing down what I know. And again, I am using my idea of position equals velocity times time. And the things that are given to me in this word problem is I know my position. I'm at the bottom of the Challenger Deep, which means I am negative 35,814 feet. So I should write my feet there. I also know my velocity. It's given to me in the problem. My velocity is -3 feet per second because I am descending. So there's my velocity right there. And then the thing that I don't know is what the time is. That is my great unknown. So I can start to write this down as the equation where my position equals my velocity times my time, and I'm just going to use t to represent this. Using our understanding of one-step algebra from last year or from just the fact families we've been doing this year, we know that if 3 times t equals, or I'm sorry, -3 times t equals -35,814, then we can say -35,814 divided by -3, remember that fraction bar right there just means division, is going to equal t. So we can go ahead and do that calculation. Negative divided by a negative is a positive number, and we then know that our time equals 11,938. So we need to go back to our story and make sure we have the context and the units correct. So that's our time in seconds is going to be 11,938 seconds. It's a lot of seconds. Okay, so now we're being given a different scenario. The same ship, we're at the very bottom of the Challenger Deep, and now it is going to take 10,800 seconds, which is 3 hours, to ascend, so we're moving up, back to sea level. Using the same relationship where we have position equals velocity times time, how can we calculate the velocity? Go ahead and pause this and look back at the work we just did and see if you can figure out the relationship. So here's what I set up, what we know. We know that our position This time I'm using 35,814 because, again, we are ascending. So this is going to be positive motion. We don't know what that velocity is, but we do know that, so our velocity is unknown, but we do know that our time is 10,800 seconds. All right, so we can go ahead and then write our equation where we have positive 35814 equals an unknown velocity, so we'll just call it V, times 10,800. So if V times 10,800 equals 35,814, then because of our fact families or inverse operations, we know that if we take 35,814 and divide it by 10,800, that will give us our velocity. Go ahead and pause and do that calculation. Okay, so I got a velocity of around 3.32. And again, we need to go ahead and make sure we're looking back to the problem and see what does this number mean. And that is 3.32 feet per second. And since it's a positive number, we know that we are in fact ascending. Okay, so let's talk about some of the important ideas from today. We can represent speed with direction, which again, that is our velocity, using sign numbers, our positives and negatives. We can also do this with vertical movement or really any rate. We know that we are using positive rates because things move up in a positive direction. And we know when we are using negative rates because things are moving down in a negative direction. All right, and last but not least, let's do the you try it. So here we have a situation. We have a water bottle with a crack in it. No! And it is leaking at a rate of 1/3 of a millimeter per second. So if it's leaking, that's going to be a negative rate. So first thing I want you to do, write and solve an equation to represent the change in volume of the bottle after 1 minute. And then if the water had 400 milliliters of water in it, how long until it all leaked out? And just to get you started on that one, let's go ahead and represent that 400 milliliters as a negative because we're looking for when that all leaks out. So that's just a little hint. All right, pause and see what you do. All right, and here are my answers. So we've got that it is leaking 20 milliliters per minute, so it's a negative 20. And that in 20 minutes, it'll all be gone. Dun, dun, dun. All right, move on to your journal problems. Good luck, y'all.